This is a video about using oxidation states to balance redox equations. And you can see the question at the top. It's a bit small, I'm afraid, but hopefully you can have a look at that as we go through. So it says that we have manganate ions, MnO4 2-, reacting with sulfite ions, SO3 2-, to make sulfate ions, SO4 2-, and manganese, so Mn2+, manganese 2+ ions. And the first stage with these equations is to always work out the oxidation states for everything and to see what's gone up and what's gone down and use that to balance the different species. So first of all, we've got oxygen. Oxygen is almost always -2, and this isn't an exception. So all the oxygens here are -2. And then have a look at the manganese. So here we've got manganate ion, so MnO4 2-. So overall, the charge on the ion is 2-, so overall oxidation state is 2-. So we've got Mn, then plus -2 times 4 for the oxygen equals 2-. So manganese -8 is -2. That means the manganese here is +6, and actually it does say that in the question. The sulfur here, again similar procedure, sulfur and 3 times -2, and again the charge is -2 equals -2. So sulfur -6 is -2. So here the sulfur's oxidation state must be +4. Over on this side with the sulfate, similar procedure, sulfur plus -2 times 4 equals -2. So sulfur -8 equals -2. So your sulfur must be +6, and the manganese is a straightforward ion here, so it must be +2. So the next stage is to use those oxidation states to look at what is being oxidized and what is being reduced, and how many electrons are involved in each of those processes. So you can see the manganese has gone from +6 to +2, so that's gone down by 4. It's been reduced, and that involves gaining 4 electrons. And the sulfur has gone up by 2, so that's been oxidized and has lost 2 electrons. So straight away we can see that we haven't lost the same number of electrons as we've gained, and that's not possible. We can't be losing electrons in our reaction, so we need to make sure that we're losing and gaining the same number of electrons. And the way to do that is to have twice as many sulfurs. So if I have 2 sulfurs, then each of them will go up by 2, which means in total they will go up by 4. So then this one's been oxidized, and each sulfur has lost 2 electrons, so in total it's lost 4. The manganese has been reduced, so it has gained 4 electrons, so that balances. So I can see if I've got 2 sulfurs, that means I need 2 of the sulfites here, SO3 2-, and 2 of the sulfates there, SO4 2-. So to start with, we've now balanced these species we've got here. If you go back to the question, it also says we've got acid solution. So if step 1 is using the oxidation states, step 2 is balancing the charges. So at the moment we won't have equal charge on both sides, and we can't lose or gain electrons. We also can't lose or gain charge. So we need to add something in order to balance the charge. And the fact it says in acid solution gives us a clue. So to balance the charge, we add some H+. But first of all, let's have a look at the charge. So I'm going to put charge here. So over here I've got -2 and then 2 times -2, so overall that is -6. And on this side I've got 2 times -2, that's -4 plus 2, so that is -2. So I have -6 on this side, -2 on this side. So if I am working with H pluses, I want to add 4 H pluses on this side in order to make sure that I've got -2 instead of -6. So if I put 4 H pluses over here, then let's check our charge is a bit better now. So now I've got +4 -2 -2 times 2, so that's -2. And over on this side I've got 2 times -2 plus 2, which is -2. So that's okay. Charges are now balanced. Then we need to just check all the other elements. So this normally means normal balancing for elements in terms of hydrogens and oxygens. So what you can add, we've already added H pluses in order to balance the charge. And then we can add waters and oxygens to balance the elements. So let's have a look at what we've got. We've got 4 H pluses over here and none over here. So I need 4 H's on this side. So I can add some waters. So I'll add 2 waters over here. And then I need to check my oxygens. So we've got 4, this is checking oxygens. We've got 4 here and 2 times 3, 6 there, so that's 10. Over here we've got 2 times 4, that's 8, plus 2, that equals 10. So actually the oxygens are balanced already. So that should be our finished equation. We've got 4 H pluses reacting with the manganate 6 ion, so MnO42-, and the sulfite ions, 2 of the sulfite ions, SO3 2-, and that makes 2 sulfate ions, a manganese ion, and 2 water molecules. So just to recap the process that you go through, we have step 1, work out oxidation states. Step 2, balance the species being oxidized and reduced. So in this case, that was the manganate, sulfite, sulfate, and manganese. Then add H plus to balance the charge. And finally add water to balance the H, and oxygen to balance the O. This last stage here wasn't necessary. I've gone off the bottom of it there, but there we go.